Bright Tuty. Every student matters.
There is another question that says you have to draw the graphs of the following value of the table with suitable scales on the axis. So cost of apples is given. The first one, cost is given and number of apples is given. If the number of apple is 1, the cost is 5. If it is 2, it is 10. If it is 3, it is 15. 4, it is 20 and 5, it is 25. We see when we increase the number of apples, the cost is also increasing. So we have to draw a graph. So what we will do, on one axis, we will represent the number of apples. So suppose I show here number of apples on x-axis. Okay. Then we represent number of, or we say the cost, right? So we will represent here on y-axis the cost of it. So you have to use your scale and draw out a straight line over here. So suppose this is our y-axis and here we are representing what? The cost in rupees. So what is the number of apples that we start with? With 1 and up to 5. So just see here, we will represent, there are 1, 2, 3, 4. So here the complete one box, okay, that has 4 boxes in it. So it is representing 1, it is representing 2, it is representing 3, it represents 4 and it represents 5. So what is the scale we are taking? That 1 centimeter, that means one complete box, or you can say 1, 2, 3, 4. These 4 are taking 1. Now on y-axis we have to represent the cost. So the cost is like 5, 10, 15, 20, 25. So we can represent it like here 5, 10, 15, 20, 25, then 30. So cost of one apple is rupees 5. So this is the first point. 2 apples the cost is rupees 10. 3 apples the cost is rupees 15. For 4 it is 20 and for 5 it is 25. So 25 is here. When we join them, definitely we are going to get a straight line. Right. So yes, the graph is a linear graph. Now, so we have represented using a graph this data which was given to us. So you also have to use your scale, your pencil, all the geometry material that you have to form it a proper one. Also you need to write down the scale. Like suppose in your graph this is one box or 1 centimeter, it is equal to 1 apple. Right, this is x-axis and on y-axis 1 centimeter is representing 5 rupees. Clear? Moving ahead, there is another question. Distance traveled by car is given. Time is given 6 a.m., 7 a.m., 8 a.m. and 9 a.m. So we'll represent time on one axis and we'll represent distance on another axis. So here we have to draw it. So we'll draw out. So I'm drawing the y-axis and then here the x-axis. So I'm just drawing it roughly. You use your scale. So it is x, it is y, and this is the origin where 0, 0 is there. So what do we have now? We have the time as 6 a.m. Okay, then the second time that we have is 7, 8 and 9. So we'll write 7 a.m., then 8 a.m. and then 9 a.m. Okay, these are the time that are given. Now 40, 80, 120 and 160 is the time that is given to us. So we'll represent, suppose this as 20, or we can just start with 40 also. So 20, 40, then 60, then 80, like this we can represent. Also you can just represent with another value so that all the values come up here. So I'm taking this as 40, this as 80, this as 120, this as 60. So here what are we representing? We are representing the distance here, and that too in kilometer. Okay, so 6 a.m. the distance covered is 40. So here 7 it is 80, then 8 it is 120 and 9 it is 160. So when we join them, yes, we get a straight line that passes through all of these points. Clear? Moving ahead, there is another question. So based on the previous question, they are asking how much distance did the car cover during the period 7:30 to 8. So we see here 7:30, this is 7:30, 7:30 to 8, what is the distance covered? So if we see this is 7:30, so let us join it here. So if this is 7:30, we'll get it here. Right? So at 7:30, distance covered is, it is 80, then it is, see, 20, 20, and we have, this gap is 40. right? So in between this, between 80 and 120, when you add them, so 120 and 80, you get 200 by 2, so that is 100. So the distance covered is 100, and at 8, this is 730. So at 8, the distance covered is 120, and here it is 100. So what is the distance covered? 20 kilometer distance is covered in that half an hour. The next question, it is asking what was the time when the car had covered a distance of 100 kilometers since it starts. So total 100 kilometers you have to see in the graph. So where is 100 kilometer? It is 100 kilometer, right? So how much is the time? It started like from 6, right? So 6 to 7 and 7 to 7:30. So it has taken 6 to 7 1 hour, then 7 to 7:30 1.5 hour it had took. Clear? So the next question is here. Here deposit and simple interest is given. We have to represent it using the graph. So we have to also tell that does this pass through the origin. So let us see whether this is a straight line graph or not, a linear graph or not. So let's draw the graph. On one axis we will show the amount deposited. On one axis we will show the simple interest, that is in rupees. Both of them are in rupees. Now we also have to tell whether the graph passes from origin or not. Then we have to use the graph to find the interest on rupees 2500, and then if the interest is rupees 280 per year, then how much is the amount deposited. So the graph will look like this, where we have taken scale on x-axis, that is 2 centimeter, that means 2 boxes represent 1000. So next 2 boxes will represent 2000, and on y-axis 1 centimeter is representing 80 units. So we know the first one, you can see here, on 1000 rupees the interest is rupees 80, right? So 1000 comma 80, then 2000 comma 160, 3000 comma 240, and 4000 comma 320, that is the value given, and for 5000 we have rupees 400. So that is plotted here, and it is a straight line. So will it pass from origin? Definitely. When you extend the line, it is going to pass from origin. It is a straight line, linear graph it is. Now the next question, for rupees 2500. So you see here 2500 is this amount, and at this amount if we match the value of y-axis, that is here, this value, right? So this is 160 and this is 240. So 1 unit is representing 80. So the mid value will represent 40. So 160 plus 40 is 200. So on rupees 2500, the simple interest will be 200. The next question is, if the interest is to be rupees 280 per year, then how much is the amount to be deposited? So if it is 280, just see 240, then this is 280. So draw perpendicular on this line, and from here also. So what is the amount that we get here? Here it is, just to see, 3000 and this is 4000. The mid value is 3500. So 3500, if this is the amount, then the simple interest is rupees 280. Moving on to the next question, they have given a side of square and the perimeter is given, and we have to show whether it's a linear graph or not. So we will take the side of square on one axis, that let it be x-axis, and perimeter on the y-axis, that we can represent, and let us see it is a linear graph or not. So you need to take a graph paper, and when you are going to draw it, it is going to be like this. So on x-axis 1 centimeter is representing 1 unit, and on y-axis 1 centimeter is representing 4 units. So 1, 2, 3, 4, 5, 6 we have represented here, and 4, 8, 12, 16, 20 and 24, that is the perimeter is represented here, the side is represented here, and it is of a square. Now the first one is, when the side is 2, the perimeter is 8, that is 4 into 2. The second, when it is 3, it is 12. When it is 3.5, it is 14, and the next is when it is 5, it is 20, when it is 6, it is 24. So we see that a straight line is obtained here, and it is a linear graph. So they were asking that you have to represent this in the form of a graph and then check whether it's a linear graph or not. So yes, it is going to be a linear graph. Similar question on area, we have the side of square is given, and then we have to write the area. So you know the area formula for the square is side into side, that means square of the value of the side. So see, the squares are written here in the table. On one side we'll take the side, on one side we will take the area. So just see, the graph would look like this. Here the sides are written and here the area is written. So when we are going to join them and plot the points here on the graph, as you now are very much familiar with drawing the graph or plotting the points, so we see it is not coming up a straight line, right? Just see, it is like this, and then it is like this, then it is like this, and then it is like this. So it is not coming up a straight line, so it is not a linear graph. Clear? So what we have done how to plot the points, how to get the linear graph. We can check whether it would be a linear graph or not, whether the line would pass from the origin or not. So this is all there, except data handling that we discussed. So this is the advanced topic that we have learned in the new chapter is linear graph. So that's all for this session now. So stay tuned for more upcoming videos. Thank you.